Alright, we're back with another improper integral calculation. I wanted to pick this one. It's one of the basic ones. You might have already seen it. I actually can't even remember what we posted, but I like this problem because we can do it in 3 different ways. Okay. The first thing that we want to do is just check to see if it's convergent. Alright. We have a really nice hint here. Our interval, alright, is from 1 to infinity. And I just have a constant over some sort of monomial cubed. Okay. Anytime I see a rational function, inside an improper integral, I want to think comparison test. Okay, every time, every single time. All right. The integral might end up diverging, right? We have the p-test. Okay, so I want to compare to a p-test, or to an integral that has that satisfies the p-test. An integral might diverge, and we might be done. Okay, best case scenario. So let's just look. So step 1, just we want to compare. So on 1 to infinity, 2x plus 1 is certainly larger than x. Okay? For all values bigger than 1, that is certainly true. Okay? That means that 1 over 2x plus 1 is less than 1 over x, which gives that 1 over 2x plus 1 cubed is less than 1 over x cubed. Okay, this is great. Alright. Integral from 1 to infinity of 1 over x cubed dx converges by the p-test with p equal to 3. That's bigger than 1. And the integral from 1 to infinity of 1 over 2x plus 1 cubed dx is less than 1 to infinity of 1 over x cubed dx. So we know from 1 to infinity of 1 over 2x plus 1 cubed dx converges by the comparison test. Great. Okay, so we're going to get a value. Alright, so we might make some algebra mistakes and get this thing diverges, but we've done the work to know that it should converge. So we'll go back and check our algebra. Okay. So now it's worth our time to do it. We can. We have 2 options, 3 options. If you're comfortable, you can kind of just do the integral from scratch, but we're going to go really slow here. So the method that I would try to do, since it's just a monomial, there's not really anything going on, I would just do u sub. I would say u equals 2x plus 1, du equals 2 dx, so 1/2 du equals dx, u of 1 is equal to 3, u of t is going to equal 2t plus 1. I did the substitution first. Like, we'll have to come back and fix these limits, but I just wanted to jump in and highlight the u sub. So we're going to have 1 to infinity of 1 over 2x plus 1 cubed dx is going to equal the limit as t approaches infinity. Integral from 1 to t of 1 over 2x plus 1 cubed dx, which is now going to equal the limit as t approaches infinity, the integral from 3 to 2t plus 1 of 1/2 times 1 over u cubed du. And just like we did in the last problem, we're going to do step 1. We're just going to solve the definite integral. So this is going to equal -1/4 u to the negative. I said it and didn't write it. So this will equal -1/4 u to the -2 from 3 to 2t plus 1. So this is going to equal -1/4 over 2t plus 1 squared minus -1/4 over 3 squared. So this is -1 over 4 2t plus 1 squared plus 1 over 36. Step 2, evaluate the limit. So with our work, we have the integral from 1 to infinity of 1 over 2x plus 1 cubed dx is now equal to the limit as t approaches infinity of -1 over 4 times 2t plus 1 squared plus 1 over 36. So that's great. We've taken this improper integral, the 7.8 question, and reduced it down to a question that we solved in chapter 2 of Calc 1. T is in the bottom. T goes up to infinity. This whole thing goes to 0. So I get 0 plus 1 over 36. And that equals 1 over 36. Da-doom. Great. Okay. Now, maybe you didn't see the u sub. Maybe you saw a rational function. All right, you panic. This happens on exams. I hope you look for u subs first before going on, but you're like, I have a monomial in the denominator. I know I can do partial fraction decomposition. Let's see what happens. So, the integral from 1 to infinity of 1 over 2x plus 1 cubed dx is going to equal the limit as t approaches infinity of the integral from 1 to t of 1 over 2x plus 1 cubed dx, which is the limit as t approaches infinity from 1 to t of 1 over 2x plus 1 times 2x plus 1 times 2x plus 1. Alright, I have no idea if this works. I mean, it should theoretically work. I don't know how gross it's going to be. But just in case, I still have a backup plan. Alright, sometimes you can't be smart all the time. You gotta just brute force it. So, step 1, solve the integral with t. So we're now going to evaluate from 1 to t 1 over 2x plus 1 cubed dx. We're now going to say is 1 to t a over 2x plus 1 plus b over 2x plus 1 plus c over 2x plus 1 dx squared and cubed. Alright, caught myself, almost made a terrible mistake. Alright, repeating linear terms. Alright, every time it repeats, we want to get all the powers. This repeats 3 times, so I should have a single power term, a squared term, and a cubic term. Okay. So that means we now need to solve for A, B, and C. 1 over 2x plus 1 cubed equals a over 2x plus 1 plus b over 2x plus 1 squared plus c over 2x plus 1 cubed. That's going to imply, after I cross multiply everything by 2x plus 1 cubed, 1's going to equal a times 2x plus 1 squared plus b times 2x plus 1 plus c. We can reduce this and make this a little simpler. So if x equals negative 1/2, okay, then we're going to get 1 is going to equal a times 0 plus b times 0 plus c. So that implies c equals 1. So I like to come back up here and make like a little box. So c is 1. Still got to find a and b. So it simplifies our system a little bit, but we're still going to have to actually go back up and solve a system of equations. So continuing on, 1 is going to equal a times 4x squared plus 4x plus 1 plus 2bx plus b plus 1. Okay. So now we want to compare like terms. Let's go ahead and actually get rid of both of those as well in the process. So 0 is going to equal 4ax squared plus 4ax plus a plus 2bx plus b. Well, let's look at the let's make this as easy as humanly possible. All right. There's only one thing with an x squared. So there's no x squareds over here. On the left-hand side, there are no coefficients in front of any x squared terms. So that means 0 equals 4a. And there's nothing over here that has an x squared other than a. So I definitely want to pick that. That's fantastic. And then let's just combine constant terms because it's easy. So my constant on the left is 0. That equals a plus b. Whoa. Whoa. Okay, so what's that mean? It means we just found our integral is 1 over 2x plus 1 cubed dx. It didn't really help at all. So there you go. You go through, you realize you don't want to do it, you're back to your original, and we just go back and we try something else. Alright, so if you don't remember, we get 1 over 36.